So what is the Ohm's law? Actually, Ohm's law shows a relation between the voltage, current, and resistance. What is the voltage? Voltage is a driving force, the force which is pushing the charges, that is called voltage. What is the current? Current is the movement of the charge. When the charges are moving through a circuit, we call that as current, the flow of the charge. And the property of a material which stop the flow of the charges, what we call that as resistance. So basically, in a circuit, there is a relation between the voltage, current, and resistance. And the law which explains the relation between the voltage and the current, that is known as the Ohm's law. So according to Ohm's law, what it states, the voltage, what is the voltage? Voltage is a driving force. The pushing force or the driving force, the force which pushes the charge. What is the current? Current is the flow of the charge. How many charges are moving through a circuit in 1 second? That is known as the current. And what about the resistance? Resistance is a property of a material to stop the flow of the charges. That is called resistance. So according to Ohm's law, if we keep resistance same, if we are not changing the resistance of a circuit, according to Ohm's law, if we push the charge with a greater amount of force or energy, then the charge will move faster, or in short, we can say that voltage and current are directly proportional if the resistance of a circuit is kept constant. So if we are keeping the resistance same for the circuit, if we apply more voltage, then the circuit will have a greater current. So voltage directly proportional to the current if the resistance of a circuit is kept constant. So when two quantities are directly proportional in mathematical relation, when we sketch a graph between the two quantities which are directly proportional, so there will always be a straight line. Ideally, in ideal cases, voltage should be directly proportional to current. This is ideal case. So if we have an ideal resistor, a resistor which resistance is kept constant, resistance is not changing. So when we increase the voltage, whenever the value of the voltage is increased, the value of the current will also increase. So we can say V and I will be directly proportional. And whenever the two quantities are directly proportional, there should be a straight line, or there will be a straight line which is passing through origin. So this graph shows that current and voltage, or voltage and current, are directly proportional. This is ideal case. And what about the slope here? What slope represent when we have current on y-axis and the voltage is on x-axis? The slope is actually reciprocal of the resistance. Slope is 1 by r. So if we find the slope and we take a reciprocal, so we can work out the resistance. So if we have two conductors or two resistors which are having same resistance, example 100 ohm and another one also 100 ohms, and we connect two different supplies. The first one we connect with a 10-volt supply, and the second one we connect with a 20-volt supply. So we have two circuits which are having the equal resistance, but we connect them with a different supply. The circuit A is connected with a 10-volt supply and circuit B is connected with a 20-volt supply. So if we keep the resistance same, according to Ohm's law, that voltage is directly proportional to current. So the circuit which receives more energy per unit charge, in that circuit, the charges will move faster, or there will be a greater rate of flow of the charges. So circuit B, the current will be more than circuit A. So basically, this is an ideal case. Ideally, what happened? We consider that the resistance is constant or resistance is not changing. But practically, what happened? The resistance of a substance can change, resistance of a substance can increase, can decrease. So if we have three different components, one is the ideal resistor, another one is a filament bulb or a lamp, and the third one is a thermistor. This is a circuit symbol for thermistor. For example, the first one is the ideal resistor. Ideal resistor means resistance remain constant. The characteristic of ideal resistor that its resistance does not change. The second one is a filament bulb. Or a filament lamp. For a filament lamp or a filament bulb, when the current is passing through this filament, current produces a heat, and because of that heat, what happened? The particle, because it is made up of a tungsten metal, and for metal, what happened when the temperature increases, its resistance also increases. So for a filament bulb, resistance increase. And the third one is actually a thermistor, which is also known as a heat resistor. Thermistor is a semiconductor. So practically you don't have ideal resistor. This is just a case, like theory is there. Practically we don't have ideal resistor. Filament bulb, which is made up of conductor, and thermistor is actually a semiconductor. And we discussed the relation between the temperature and resistance for the conductor. Resistance and temperature are directly proportional to each other. If we increase the temperature, or if the temperature of a conductor increases, the resistance will also increase. And what about a semiconductor? It is opposite. At high temperature, semiconductors will have low resistance. So as the temperature increases, the resistance of a semiconductor will decrease. And reason we already discussed in the last session, that what is the reason why the resistance for a semiconductor decreases and for a conductor increases. Now, what we did, we connect all of them by a supply. We have a supply here. We connect an ammeter to measure the current, and we connect a voltmeter to measure the voltage. Same thing happened for a filament. We connect a voltmeter to measure the voltage, and we connect an ammeter to measure the current. And for thermistor as well, we connect a voltmeter to measure the voltage, and we connect an ammeter to measure the current. And we are sketching a graph between the voltage and the current. Current is on y-axis and the voltage is on x-axis. So on y-axis we have current and x-axis we have voltage. Same thing here. We have current on y-axis and voltage on x-axis, and we have current on y-axis and voltage on x-axis. Current is in ampere and voltage is in volts. Whenever you label the axis, always the quantity / the unit of the quantity. So we have current on y-axis and voltage on x-axis. Now, according to Ohm's law, what Ohm's law states, it states when we increase the voltage, the current will also increase. That is Ohm's law. So for an ideal conductor, for ideal resistor, for which the resistance remain constant, resistance does not change. So when we increase the voltage, the current will also increase and it will always be a straight line. This is for ideal resistor. Practically, we don't have ideal resistor because even whenever we are passing a current through a resistor, the heat produced and its resistance does not remain same, it changes. But ideally, we assume resistance is constant. So whenever we sketch a graph between voltage and current, so it will always be a straight line for ideal resistor. And remember, the slope of this line is reciprocal of resistance. But resistance is not changing. That's why the slope is not changing. But what happened for a filament, when we switch on the filament and we increase the voltage, so initially the current also increases. But then what happens, because for a filament, it is made up of a metal tungsten, and for metal, when the temperature increases, as we are using a filament, so as the temperature increases, its resistance will also increase. And what is the effect of increase in resistance? So as the resistance increase, what we observe, will observe slope of this graph start to decrease. So in the beginning, it was a straight line, but then what happened? As the resistance start to increase, the slope start to decrease. So it appeared to be curve. And for a thermistor, thermistor is a semiconductor. When we pass the current, current produces heat. And because of that heat, due to the heating effect, the temperature increases. So when the temperature increases, what happened to resistance of a thermistor? That decreases. And here also, what slope represent? Slope is reciprocal of the resistance. So when the temperature increases, the resistance decreases. So as a result, resistance decreases. What happens? The slope will start to increase, because when current is on y-axis and voltage is on x-axis, the slope is reciprocal of the resistance. So first the resistance was not changing, but then what happened? Because the temperature increases due to the current, and the increase in temperature reduces the resistance of a semiconductor. As the resistance decreases, the slope of this graph will start to increase. So it will, the curve inclination or the slope or the gradient will start to increase for a semiconductor. So these are three different graphs for three different material. For ideal conductor, it will follow the Ohm's law. According to Ohm's law, voltage and current are directly proportional. But for a filament and thermistor, they are not ideal devices, they are not ideal component, so they don't follow the Ohm's law. In the beginning, for a very short or a very small voltage, it follow or obey the Ohm's law. But once the temperature start to increases, their resistance decrease, and voltage and current are not directly proportional. So it appear to be a curve. So ideal resistors are known as ohmic device. Ohmic device means they follow Ohm's law, but filament, thermistor, they are non-ohmic. What is the meaning of non-ohmic? Means they don't obey the Ohm's law. And what is the Ohm's law? Ohm's law states that if we increase the voltage, the current will also increases. A voltage and current are directly proportional to each other. As you can see in this question, figure 9.1 shows a graph of a current against the potential for a filament. So they're asking, state what happened to the resistance from 0 to 1 volt. So from 0 to 1 volt, it is a straight line. And after 1 volt, yeah, that's right. So as it is a straight line and we know the slope whenever a current on y-axis and voltage on x-axis, what the slope represents, the slope is reciprocal of the resistance. Because the slope is not changing, it means the resistance is not changing. So we can say that the resistance is constant. But for the second part, what happened? The slope, yeah, that's right. So slope start to decrease, and we know the slope and resistance are reciprocal. So if the slope is decreasing, it means the resistance is increasing. So the second part, we will write that resistance is increasing. So from 0 to 1 volt, it was constant. It was obeying the Ohm's law. But later what happened? The resistance start to increase, because how we identify resistance is increasing, because the slope represents the reciprocal of the resistance. So if the slope is decreasing, it means the resistance is increasing. Okay, another question. As you can see, this is also a similar question. The voltage is on x-axis and the current is on y-axis. So what the slope represent? Slope is reciprocal of the resistance. Now, the question is, the potential applied across the resistors is increased. Take the box that indicate the effect on the resistance. So for a resistor, resistance of a resistor, this is a line for the resistor. So which box I should take? You can use the screen annotation to take a box. Here slope is not changing. If slope is not changing, which box I should take? Yeah, that's right. Because if the slope is constant, it means the resistance is constant. So I should take the second box. Then when you check for a filament, a lamp or a filament bulb, so for a filament bulb, what happened? The slope start to decrease. If slope start to decrease, what happened to resistance? So resistance start to increase. So I should take the first arrow, which shows that the resistance is increasing. Then the last part, we need the potential across the lamp is 6 volts. Calculate the resistance. So the formula to calculate the resistance is voltage divided by current. So using the graph, because we need a resistance of a lamp. So how to work out? We will take, as the voltage is 6 volts. So we'll use this graph. When the voltage is 6 volt, what is the current? If this is a 6 volts potential or the voltage across the filament, how much is the current? So it appeared to be 2 boxes above 4, I guess. And each box is representing point, because there are, as you can see, 10 boxes represent 2. So each box is representing 0.2. So 4.2 and 4.4. So the current is 4.4. So we have the voltage across the lamp, which is 6. And we have the current, which is passing through the lamp. That is 4.4. So 6 divided by 4.4, voltage divided by current will give us the resistance. So 6 by 4.4, that is equal to 1.36 ohms. Then another question, as you can see, so see a similar type of questions are there. Calculate the resistance of a thermistor when the voltage is 7. So what we will do, when the voltage or the potential is 7, we will draw a line. And for thermistor, we'll draw a line. Thermistor and resistor have a same resistance at 7 volts. And then we will find how much is the current. So when the potential is 7, what is the current? Each box, again, each box is representing each box is representing 0.2. So this is how many boxes? 1, 3 boxes are there. So 4.2, 4.4, and 4.6. So the current here is 4.6 and the potential is 7. So resistance is the ratio between voltage and current. So that is 7 divided by 4.6. So 7 by 4.6. Which is equals to 1.52 ohms. Then in table 9.1, tick the box that indicates the effect on the resistance of a thermistor when the potential across them increase from 0 to 7. So what happened to resistance of a resistor? Tick a box, use the screen annotation. So because it is a straight line, so for a resistor, because it's a straight line, so slope is constant, it means the resistance is constant. But what happened for a filament? As we know, the slope is reciprocal of the resistance. As the slope start to increase, it means the resistance is decreasing. So that's right. Last column will take for thermistor, and for resistor, it was a constant one.